All right, I think we can get started. Um, Good afternoon, everybody. I think it's 12 past now. So good afternoon, everybody, and thank you so much for joining this session on a Saturday. I know what it takes to really wake up and then join a technical session, and it's not be like yet another Teams meeting we are joining in, right? We all are having that particular what to say. It's an overdose for all of us. But yeah, you guys have taken time out of your personal lives and come in here. Thank you so much. That's really the motivation for us to do more of these events. Right. So before we get started, yeah, this is the title of the session. So we're going to talk about Azure Container Apps with .NET. And as I see from the poll, not many have really used Azure Container Apps. So that's a good thing. So I hope you'll be able to learn something new today. There are quite a few guys who used Azure App Service and then quite a few who have used also Azure Kubernetes Services. So I'll also draw parallels between how these particular offering fits between both of these or also fit across the all the containerization options present within Azure, right? Before we get there, a quick intro about myself. So my name is full name is Swaminathan Vetri. You can call me Swami, like I said, and I work as a cloud solution architect at Maersk. I used to be a .NET developer until I became an architect. So .NET was my primary area forte until I became an architect. And now since I'm a solution architect, I'm focusing more on the cloud part. So cloud native solutions and Kubernetes, Azure, DevOps, .NET, all the different areas which I focus on. And I'm also a mix of MVP and developer technologies, and those are my Twitter and GitHub handles. So whatever the demo I'm going to show, it's all already available in GitHub. I'll share those links as well. And the slides are also built using the learned content. I'll also share those links on from where I picked up some of these pictures, other content and other things, right? And yeah, I used to write blogs at swaminathanvetri.in. The past couple of years, it's kind of slowed down, not really been very active, but yeah, I still have that. And apart from this, yeah, I like photography, traveling. I do a bit of dance as well, and then I play a lot of table tennis and more interest in home automation. And yeah, I think I missed one more thing. On a personal side, I'm married and I have two kids who keeps me always busy throughout the day. Right. All right. So now moving on. So this is the agenda. It's a very short one. Like we'll start understanding what and why of container apps, and then let's understand some of the concepts of container apps, and also let's look at the comparison of various containerization options, right, between whatever is present in Azure, and finally we'll look at the demo of how we can easily deploy and scale .NET apps, right? It's more of an Azure Container Apps focusing, but what we're going to use is we're going to use a .NET 7 based web API, and then we'll see how we can quickly deploy it, and then how we can scale it, and things like that, right? So what are container apps? This is the definition from the documentation. So these are Azure Container Apps enables you to run microservices and containerized applications on a serverless platform, right? So how many of you are using microservices? You can just raise your hand if you don't want to answer it. Hopefully, I'm expecting few people have heard about microservices and using it actively, right? Yeah. I'm more used to doing more interactive sessions, so please feel free to raise your hands, or if you want to unmute and talk, also please do that. And if you have any questions, raise your hand. I'll take a look at the chat window here, and then I'll pause, and then we can take questions along the way. Okay. I see quite a few guys have raised hands for microservices, right? Yeah. So container apps is something which can enable you to run microservices and containerized applications, not necessarily microservice architecture, but anything you can containerize it, then you can run that on Azure Container Apps, right? And the platform that's going to run is completely serverless. That's where it is. It's much differentiating between Azure App Service or Azure Kubernetes Service, right? And we'll understand how it is different along the way. And yeah, so some of the scenarios where we can use it is, let's say if you want to enable any endpoint, an API endpoint or sorry, then, and if you can containerize that API, for example, a .NET Web API, you can put it into Azure Container Apps. Or if you want to have any kind of a background processing, right, which if you want to have some sort of, and continuously, if you want to run certain background running process to update the database or get data from the database and then transform it and then push it into some other database, etc., you can use Container Apps for that. Or in the case of event-driven processing, for example, if you are working with a message-driven architecture or event-driven architecture, where you use something like Azure Service Bus or Kafka for that matter, right? If you are having those as your event systems, and if you want to write your producers and consumers, etc., right? In all those cases, also you can deploy your producer API endpoint or your consumer service, etc., into Azure Container Apps, right? And of course, the last one is microservices architecture, where a single big application or single problem statement can be solved by building different microservices, right? So microservices by itself is a bit different topic to discuss. Maybe if there are any specific questions, we could take it up along the way. But in general, yeah, let's say, for example, if you're creating an ordering system, that's one of the classic example we all can relate to, right? Your ordering could be one microservice, your search could be one microservice, displaying your products could be one microservice, right? So you build a lot of these microservices and then they all compose and then they form a big application. right? So if you want to deploy all of these different services into an infrastructure, serverless infrastructure, that's where you can use Azure Container Apps for. Okay. And another call out, I'm so used to talking so fast. If in case the pace is high, please let me know. I can also slow it down, right? All right. So yeah, so now getting into the concepts of the container apps, right? So first thing is the environment, right? So that's like the logical boundary what you are going to create. So the moment you want to create any container apps, the first thing what you want to create is an environment, right? So environment, as it's mentioned here, it's a secure boundary around a group of container apps. As you can see in the picture, there can be container app 1 or container app 2. You can deploy multiple container apps into the same environment, and all of these will sit inside a single virtual network, right? And there's an option also to give, if there's a custom virtual network we want to use, we can use that as well. But yeah, in principle, it's all, if you have one virtual network, you create an environment in that virtual network, and all the different microservices, sorry, not the microservices, different container apps can be deployed into that particular environment, right? So the reason, I mean, why you would do that is, let's say if you are in the example of microservice architecture, you want to have all of them deployed into the same virtual network, and if you want all of them to log into the same log analytics workspace so that you can have your end-to-end tracing and everything properly, right? Then you can use something called an environment, right? So top level is like the environment. That's what you will create. And environments is what is going to comprise multiple containers. So this is what is the use cases for environments. You can manage related services like you called out in the case of microservices, service A, B, C to whatever n number of services you want to have. You can have all of them deployed into a single environment, right? And if you want to deploy all of them into the same virtual network, you can use that. And there's also something called Dapper. I'm not sure how many of you have heard about Dapper. Dapper is nothing but distributed application runtime. That's again on the cloud native world of things. So you can have a sidecar that will take care of some of your prospecting concerns, like your authentication, securing your traffic between your microservices or different pods, etc., etc. So if you want to use the Dapper service, we can use environments. So we'll get into the Dapper part later. Just as a high level, you can understand that yeah, Dapper is also something which, if you want to use it, you need to have all these different services deployed into the same environment, so that they all can share the same configuration. And like I said, they also can share the same log analytics workspace. Yeah. And yeah, so ultimately what we are going to run is a container, right? So that is what is a container, is nothing but a group. They're grouped under pods. So that means you can have one or multiple images running inside container. And currently, container app supports only Linux-based images, x86 or x64-based images. And we can pull the images either from public registry or private container registries. I hope you understand what is a container registry. Right. So if not, I can quickly explain it. Right. So let's say if you are using a .NET application, typically what we used to do when you do a .NET build, it generates some DLLs, right? And then we do a .NET publish. That's gonna trim down whatever the debug related stuff, and then it's gonna give a bunch of DLLs, and that bunch of DLLs will put it into an IIS or so, as if you're using a web server, right? So you put it into an IIS, and then your application will get up and running from there, right? That's how we used to deploy these .NET DLLs. Right? Or you will publish it as a NuGet package if you're creating a class library or something, and then from NuGet packages we can download it and then reuse it later, right? Now, when we talk about Docker and the images, what happens is all your application and its acquired infrastructure dependencies, everything is baked into a single image, right? And now where do you store that image? That is where the registries will come into picture, right? It can be a public registry, like what you see as a Docker Hub is a public registry, or GitHub, GitHub also has a public registry. And then if you go with Azure Container Registry, it could be like a private registry where you can restrict access into only your enterprise, etc. Right? So that's a container registry. So you can deploy your images from either public registry or private registry as well, right? And all the containers, they share the hard disk and the network resources. Yeah, that means they are all in the same infrastructure. Under the hood, it basically they're all dependent to the same VNet. That means they are all the same infrastructure, so that they can share your network resources on the hard disk. That's why they're able to communicate to each other seamlessly, because they're also hosted within the same VNet, right? So yeah, so and let's say you have a container, and then now there's a concept called revisions in Azure Container Apps, right? So one of the good things about containerized applications, or in the Kubernetes world, Kubernetes style of applications, is the rolling updates and things like that, right? That means without any downtime, you will be able to push in a new version of your application, right? So that's what you would use in your Kubernetes service if you're using that. Let's say if people coming from app service, you have something called deployment slots there, right? Where you have one live version, and then there will be a second one, you can put it into staging version. And then the moment you test the staging, and then once you're happy with that, then you can just swap them, right? That's a deployment slot to enable zero downtime deployments, right? The similar thing if you want to do in Azure Container Apps, you would use something called revisions for that. Right. So the revisions is an immutable snapshot of a container app version. And anytime we deploy our first container app, a first revision will get created. And after that, we can start making any changes. Either it could be an application change. Let's say you've created only one API endpoint, and then as a part of your next sprint, maybe you're going to create another endpoint, maybe like in CRUD you're implementing, and then you want to create some more API endpoints, etc. Right? So these are more of your application updates. Plus, if there are any configuration updates are also, will create revisions. So for example, now your service is called service A is talking to service B, but the service B's endpoint is changing and you want to really modify that particular endpoint URL, and then that will call for a revision. So there are quite a few documented list of changes that will cause a new revision, which we'll take a look at it as part of the demo. Right. So the point is revisions are like whenever you want to deploy any incremental version of your application, then it's called a revision. Right. So and you can maintain up to 100 revisions here. And you can also maintain multiple versions can be running at the same time. So if you've heard of concepts like blue-green deployments or A/B testing or canary rollouts, etc., right? So all those are also possible with revisions here. Yeah. So as you see in this here picture here, sorry, environment is a top-level boundary. Environment will contain container app. One container app could have a revision in it, and one revision will have your replicas. That's where the number of containers will be created. Replicas is nothing but then how many number of instances you want to run. You want to run one instance of your container, or you want to run 10 instances of your container. That is what is defined by your replica. Yeah. And yeah, so this is the revision use case. Like I said, if you want to release a new version of the app, or if you want to revert to an older version, if there are any issues, if you want to split traffic between A/B testing. So in this case, as you can see, this is a container app here, and 80% of the requests would go into revision 1, and 20% will go into revision 2 here. Right? You can do this with revisions concept here. And yeah, so we just talked about what is infrastructure and then how we are going to deploy it, but what is application lifecycle here? Right? So upon first deployment, what we get is an revision 1, right? So like I said, these are multiple versions you can maintain. This is active revision, and the right-hand side is inactive revisions. And you can push in another revision 2 as an active revision, right? So that they both can coexist, or that is like an update what you do to your existing application, right? And then what you could do is, let's say once you do the testing, and if you're comfortable with revision 2, and if you want to make that as a primary revision, then you can make your existing revision as inactive. Basically, you deactivate the revision so that it becomes inactive, and then your revision 2 will become a full-fledged revision. Yeah. So basically, this is more about how the deployment will flow through, and then how your lifecycle of your application can happen. That is what I'm trying to explain in these slides. Okay, so now this is just a picture to show about how the microservices deployment will happen in container apps. So again, the environment will have container app 1 where you could deploy your microservice 1, which in itself can have its own revisions and its own set of replicas. And the container app 2 will have another microservice. Going back to my example of an e-commerce kind of a thing, search. Let's say search is what typically a lot of people will go and do first, right? And not every search translates into your orders, right? So then search microservice you might want to run maybe like a number of 10 instances you might want to run. But your other order service or your cart service, maybe you might want to run only like five instances, right? So you can manage all those with the different container apps created within the same environment. That's so they can talk to each other. So you can also deploy a microservice into multiple environments as well, but the overhead would be that it'll have to go from this VNet to another virtual network. That means there's an additional network hub that will be added. So you can very well get an publicly accessible ingress URLs. Ingress is nothing but that's the entry point to your application, right? From an external means, like outside of your cluster, right? Or outside of your container apps in this case. Right? So you can enable that, but that means if you are going out to the internet and then getting back into your application, right? Instead, you can very well deploy all of your microservices into the same environment. Yeah. Okay, so and then we just deployed. Now, how are you going to do observability, right? I hope have you guys heard of this term called observability? Yeah, quick show of hands. Does anyone want to talk about what observability is? Let's make it a bit interactive. Otherwise, it'll be in one-way lecture, which I generally don't like. Anyone want to take a stab at what observability is? Okay, heard about it? Not heard about it? Anything? So basically, yeah. How many of you write logs in your application? I hope everyone writes logs, right? Error logs, debug logs. Yeah, we keep writing those logs, right? So how do you monitor these logs? and logs is just one part of it, right? And then how do you understand what are the metrics? Basically, if you want to pull some metrics out of your application on your application response latencies, or where in your application your particular, I mean, the latency is being from which is causing the delay, basically, right? Whether it is a DB access call or is it your external API call, right? How do you understand those traces and all those stuff, right? So that is what would come under part of observability, right? How do you basically monitor your entire application post deployments, right? Be it logs, metrics, traces, and everything, right? So now, how are you going to do that in case of Azure Container Apps? So let's say if you're on Azure App Service, right? You have integration with your application insights, right? Have you guys used application insights? I hope people using application Azure App Service would have application insights enabled, right? So you can very well use that as well. But other than that, you also have different options here, right? So you can also live stream your applications. I think this is also something which is available in App Service as well. The moment you deploy your container into container apps, you can start streaming your logs. This is primarily for your dev and test environments, right? And you can also log into your container console. Right. See, because if it's, for example, if typically when we are not working with the Dockerized model, what we usually we go and look at the IIS logs, or your file logs will be written into a file system, right, in the server where your application is deployed. So we go and then look at that file system, and then we can identify what has really gone wrong, right? But with containers, it's not going to be written on the file system, right? The containers will basically, you write logs into your standard out and standard error, whatever, right? So, and those needs to be streamed outside so that those get pushed into your centralized log monitoring system. In this case, it will be log analytics, right? But that is all will happen in your higher environments. But what if you want to quickly understand what's really happening inside the container, right? So for that, you can also connect to your container console in the Azure Container Apps, and we'll also see that how we can do it in the demo, right? So that we'll understand, okay, what's really happening in that particular container. Okay, there are a couple of questions. I'll just talk about them briefly after this. Yeah. So Azure Monitor is another thing. Azure Monitor captures a lot of metrics. There are a lot of built-in metrics that gets emitted out of the Azure Container Apps, and that gets fed into Azure Monitors. And we can also see some of those default metrics available there. And like I said, monitor log analytics is the key. So you can push all of your logs into log analytics, and then we can write all these custom queries, and then we can figure out what's happening, how many replicas are running, how many, what is the CPU cycle being used, etc., etc. And yeah, of course, you can also set up alerts. For example, if a revision is deleted, or if there's a scale to 0, if you want to do it, whenever it is scaling to 0, if you want to get notified, you can do that. Or whenever your scaling is reached the maximum threshold what you have put, you can set up some alerts, right? You can do all of this with Azure Monitor alerts as well. So like I said, these first two primarily you will use in your dev and test environments, and then the last three is what you will do after you deploy your microservices or applications, right? Okay, now going to the questions here. So please cover and go to AKS versus container apps, function versus logic apps if possible. Okay, we'll talk about it, Nikunj. Okay. And then is there a use case of having container app without ingress? Yes, of course. So like I said, in the case of microservices, for example, right? Let's say if that so basically, if there's a background processing you are running, right? If your application is going to do an background processing kind of a thing, you don't need to enable an ingress. Or if your application is more of an event-driven system where you are listening to any particular event coming up in service bus, and if you want to react to it, or if you are listening to an event coming to a Kafka topic, and if you're reacting to it, then ingress might not be needed, right? Or if you're having still a microservices architecture, not every microservice needs to be enabled with ingress, right? You can have one entry point, which could be your UI app, which you are deploying into container app. Only for that, you can enable the ingress, and rest all the things will go away on internal calls. So the UI app can call to API 1, or it can call to API 2, and even API 1 can talk to API 2 or 3 or 4 using all the internal ones. So then in all those other microservices, we don't have to really expose anything outside of container apps. Yeah. And we can have max of 100 revisions. How to delete revisions? Yeah, that I'll show it in the demo. It's pretty straightforward. So on the management part of it is all either via portal. Of course, we'll do via portal only during our development and test phases, right? Otherwise, you can use ARM templates to do the automated deployments, or you can also use Azure CLI commandlets to really manage some of these Azure Container App related stuffs. Yeah. How is state management done for containers with load balancing? Okay, that's a good question. So we will talk about it in some time. Okay. Is session affinity supported? So this is primarily used for stateless kind of a thing. But if you want a session affinity would be more on your UI kind of an app, what you're going to build, right? In that, if you want to handle it, we should be. But states are also, it is also possible that you can have stateful applications running within container apps. Though I have not tried that yet. I've been trying to use primarily for the backend APIs, which are more of stateless. Yeah. How is state management done for containers with load balancing? So I think it is this related to the session affinity part. So basically, see, load balancing is taken care by the ingress what we are creating, right? In let's say if you have multiple replicas of a same microservice, right? You will expose an ingress, and that ingress will take care of the load balancing, and that will try and send the request to one of the pod which is running, other replica, one of the pod which is running there, right? If you want to maintain states across multiple things, like I said, I am yet to check the stateful implementation of container apps yet. But for stateless part, yeah, it is pretty seamless. But load balancing is something we don't have to do anything special. It automatically takes care of it when we provision the container app with multiple, multiple replicas. Okay, can I have this kind of architecture? What is this one? Application gateway or WAF? Yes, container apps with internet integration, subnet to Azure SQL. Yeah, okay, what is it? Without ingress. 1 second, I'm taking a look at the picture here. Or maybe I can also pull this so that everyone can see it, right? So what you want to do is you don't want to have an ingress for your container app, is it? Yeah, so in this picture, if you look at it, right, there is a VNet inside which your application gateway is hosted, and also your this is hosted in one subnet, and then your container apps is created in another subnet, right? So that means they can actually talk to each other because they are all hosted within the same VNet. So in this case, your application gateway will be the entry point for your external consumers of your API or UA app or whatever you're creating. I think it says member portal here, right? That means it's going to be the portal. That portal is exposed via an application gateway. So that none of your portal endpoints or your container app endpoints is backend, I believe it's called. This container app endpoints will not be visible to anyone else outside. Yeah, this is very much possible because it's all hosted within the same VNet. Okay, I hope that answers the question. If not, please unmute, or you can also uh, add your comments there. All right, so yeah, where were we? We are at observability part, right? So these are some of the ways we can really monitor how the app is running and how to troubleshoot issues with any of the apps that is running inside container apps, right? Okay, and there's also some other features which are present in container apps. So health probes, people coming from Kubernetes background might understand what is health probe. So it's nothing but, let's say we are deploying an application, right? How do we know whether that application is really, or let's say for an API, for simplicity's sake, let's say I've deployed an API endpoint, like a .NET Web API. Now, the infrastructure layer, which is the container apps here in this case, needs to know when it should start servicing the request or routing the request to my API endpoint, right? That means it should somehow understand whether the API as a microservice or an API is really ready to take any inputs or ready to start processing any requests, right? For that only we use something called health probes. There are multiple probes. One is called liveness, one is called readiness. That means liveness is nothing but whether, let's say, if your container is up and running, then it will say liveness is true or it is good. But let's say the container is up and running, but in processing is still, I mean, your web API is still trying to come up, and then it is still trying to establish communication with your backend database, etc. Then the readiness will not be there, right? So until your API is able to establish communication with your backend DB, there is no point in sending any request to that API. Right? Because obviously it's going to fail because it will say the connectivity is not established or whatever be the reasons, right? So in such cases is where we use something called health probes to understand whether the underlying API is ready to start processing the requests. That's what you use health probes for. And I also, like I mentioned, Dapper integration is another part. Dapper is nothing but distributed application runtime. That means maybe it could be a little bit of an advanced topic, but I'll try to simplify it, right? Let's say we have a microservice architecture where we are going to have maybe 5 to 6 different microservices, right? There could be a lot of cross-cutting concerns. What I mean by cross-cutting concerns is, let's say, how do you, ensure all of these microservices are talking to each other using HTTPS? That means basically that has to be a mutual TLS that needs to be enabled, right? That means each and every microservice should know or should be able to understand, okay, the call is coming from another trusted source, right? If you have 5 microservices, maybe you could try and maintain your certificates in each of these microservices somehow, and then you can make them work. But what if that 5 becomes 50 and that 50 becomes 100, right? Then the management of certificates and everything will become much more complicated, right? That's one part of the problem. And then what if the microservices also enable another thing called polyglot models, right? I'm not sure how many have heard about it, right? That means you can choose whatever the language of your choice that is going to fit well for that particular problem that microservice is trying to solve. For example, if you think search can happen with .NET faster, you can go with .NET for search. But if you think something else, maybe a DB access is faster with Go, you can go with Go for that, right? Then if the moment you have multiple such different programming languages based containers running in your environment, how do you now start monitoring all of them? How do you now start correlating the requests? How do you start having end-to-end tracing of all of your, the request is going from service A to B to C to D or whatever, right? So obviously you cannot have a common thing written because maybe you are comfortable with .NET and maybe some other team is working with Go, some other team is working with Java. How do we ensure all of these are tying together? This is one sort of an observability problem with respect to your, with respect to microservice architecture, right? Some of these are called cross-cutting concerns, and we can address all of these using something called Dapper, right? It's called Distributed Application Portable Application Runtime. So that means what it does is it is going to inject a sidecar into your container so that your application code will be intact. You don't have to make any changes to it. The sidecar will start looking at your authentication part, your MTLS part, and then your end-to-end traceability part. All of these things can be taken care by your sidecar, right? And this is something which is being used in the world of Kubernetes when people use multiple microservices, etc. But that's also available in container apps as well, right? So by now, then you've got a high-level thought that container apps are more related to Kubernetes style of working with containers, right? Not really like working with a standalone containers. If you're having a standalone containers, you could very well use the how to say your the container instances or something else, right? Just give me a second. Yeah, sorry. So this is more of you want to make a Kubernetes style based deployments, but if you don't want to take an overhead of managing a Kubernetes clusters or writing any of the YAMLs, etc., then you could very well use container apps. Okay, and then there's something called KEDA. KEDA is nothing but Kubernetes-based event-driven autoscaler. Right, you can also use KEDA for autoscaling here. So again, going back to example of event-driven architecture, right, where there is one producer microservice and there's one consumer microservice and there's a Kafka in middle. All right, to keep it simple. Now, depending on how many events are present in the Kafka, if you want to dynamically scale your consumers, right, because the producer is not going to produce in a steady state, right? If you know the steady inflow of your events, then it is fine. But if your events inflow is very sporadic, let's say maybe during maybe lunchtime is when we are going to get too many requests, right? So then you would need to auto scale only during that time, right? And on depending on the events, now number of events in your Kafka topic, you can scale your consumers. Otherwise, there's no point in running simply 10 instances of consumers and then paying for it, right? You can very well scale it down to 0 or scale it down to 1, and then you can increment it dynamically whenever the load increases, right? So to achieve that is when you can use something called KEDA. Of course, KEDA also has a lot of different other scalars in it. I just took an example of event-driven thing, but it could be multiple stuffs even for your builds. For all you are trying to create your build servers, if you want to spin up your build agents, you can also do those with KEDA. But in the context of microservices deployment, I'm just explaining more for the Kafka-based, things. Either it could be Kafka-based auto scaling, or it could be service-based, messages-based auto scaling. There are multiple other scalars available, which will also show when I go to the demo part. Right. This is also available out of the box for us. We don't have to write any additional code for it. It's all more of plug and play kind of a thing with container apps. If at all you have to do this in Kubernetes, you need to install KEDA on your Kubernetes clusters, and then you need to also create those CRDs, and then you have to create your scale triggers, and you have to write a lot of YAMLs to really get that achieved. But all of those things are abstracted for us, and then it's taken care of by container apps in here. So yeah, health probes. Yeah, we talked about this. Sorry, manage identities. People working in Azure should be able to relate to manage identities, right? That means you can create an identity for your container app, and then you can use that identity to talk to your Azure SQL DB or Azure Storage, etc., without using any connection strings in your application. That's also very much possible with this one. And of course, you can also map custom domains to your ingress URLs. You can come up with your own certificates, and then if you have a custom domain, you can do domain mapping, and then you can use that. And yeah, zone redundancy for high availability and disaster recovery. So container apps has a built-in zone redundancy. So if you enable a zone redundant container apps environment, then automatically it will ensure each of these are created in different 3 availability zones within a region, and that will help us in the DR perspective. Okay, I'll just come back to the questions in a while. And Azure Arc enabled AKS specific can also run container apps in Azure Arc enabled AKS clusters. So Azure Arc is more of an high level single pane of glass visibility you will get for infrastructure running either in Kubernetes or on Azure or on-prem or any other cloud for that matter as well, right? So if you have an Azure Arc enabled AKS clusters, you can also run this within that clusters and then you can use it. These are more like an advanced use cases where if somebody is already using it, excuse me, excuse me. Sorry about it. So if you have an Azure Arc enabled AKS clusters and if you want to run these in it also, it's very much possible. Right? Yeah. So before I go there, I'll just take a couple of questions. So we can check web API active or inactive with secure breakers, right? Yeah. So that's also another pattern. Basically, what you're talking about is resiliency pattern in microservices, right? You could very well do that. I'm not sure in which context you're asking that. But yeah, if you're looking at a design pattern perspective, yes, circuit breakers would help in doing it. Let's say you can keep on checking that, and if there is if you understand that your dependent service is down, then you can have your own fallback approach. Really, either send a cache data or do anything else for your callers, right? Okay, so we have HPA and Kubernetes. How KEDA is different from that? When to choose KEDA or HPA? That's a very good question. See, both of these works on the console of the metric servers, right? Kubernetes exposes something on metric server. That's where all the metrics are being captured, right? And if we talk about HPA, it's something about horizontal pod autoscalers. That works on, there are certain metrics which it works on, basically either your CPU load or your memory load, or if a number of requests, if it's an HTTP endpoints, etc. Right? There are only limited options on which you can scale your microservices dynamically. But when you talk about kernels, like I showed an example of event driven, right? If a Kafka consumer is there, right? If it is processing one message versus 10 message, its memory consumption might not always be going very high, right? Because you read an event, sorry, not a message. You read an event from Kafka, and then you process that event, you acknowledge it, and then you'll go and read the next event, right? So your processing cycle is going to be pretty much the same, and it might not really spike up your CPU or memory if there are a lot of inflow of events in your Kafka topics, right? So in such cases, how do you now ensure? Let's say if one event is taking about, for example, 100 milliseconds to process, right? If you're getting like 10,000 events at once, then you can always multiply how long it's going to take complete all of these processing all of these events, right? If there are so many events available in your topic, then it will always get a back pressure on your producer as well, right? So if you want to really process these in a faster fashion, then you can use SCADA to dynamically basically scale your consumer. For example, I start with one consumer, and then I'll say whenever there are like 50 events present in my topic, I want to really scale it to scale it further. You can define the minimum and maximum instances, and then it will automatically scale that, and then it will make, let's say, for example, I'm saying between 1 and 10. Right, so it can go up to 10 depending on the load, and as and when the load reduces in your topic, it will automatically bring it down, right? So like I said, the long story short, the metrics on which both are working are different. So HPA is primarily for your REST API kind of a things, but it's more for an event-driven systems. Wherever you are having it, you can use SCADA for that. App service have a very nice screen to CPU or RAM based scaling, but container app scale screen just shows a small text box how to configure. Yeah, maybe yeah, when we go to the demo part, we'll take a look at that, Kannan. Yeah. Okay, so now I think we got a fair idea of some of the concepts of Azure Container Apps. So let's quickly look at why it could be used right over the other things. So obviously, first thing is it can run multiple container versions. That's one of the key things for anyone running in a cloud native application. Right? We want to perform a zero downtime deployment, and then we need to be able to choose which version I want to use and how I can do a traffic splitting, etc. All right. So and again, auto scaling of your apps is possible. And you can also enable HTTPS based ingress without having to manage any other Azure infrastructure, because everything else under the hood is taken care of by container apps for us. So you just say ingress enable, it will automatically enable it for you. Yeah, and this is already covered split traffic we can do. And you can use internal ingress and service discovery for secure internal only endpoints built with DNS based service discovery. I think someone asked about whether can I do without without external ingress, right? That's very much possible here as well. And yeah, you can use microservices with Dapper, and you can run containers from any registry, or you can use Azure CLI extension or Portal or ARM templates to manage your applications. So no need to write any YAMLs. I'm not sure how many of you are fan of YAMLs. How many of you like to write YAMLs? Big show of hands. Okay, I don't see anyone showing up hands. I hope. Okay, there are a few guys. Good. So you don't have to actually write YAML files here, so you can manage everything via your Azure CLI or your response. Yeah, and you can use your existing virtual network. You don't have to always get a new network for this. You can very well use an existing virtual network and then get these provisioned in that virtual network itself. And you can also securely manage your secrets directly in the application. There is also a secrets area where you can go and inject it so that it becomes available across all the containers running within that particular environment. Sorry, within that app, not the environment, app level, these are. And then you can also monitor your logs using the log analytics. These are some of the reasons why you can, use this, right? Now, yeah, and the quota part is something which is very subjective to discussion depending on the scale and the kind of application what we're using. But yeah, to start with, it has a very generous quota and which you can always override to increase the limits. So yeah, so this is a comparison part which I talked about within Azure. We have, I tried to compare 4 of these aspects: Azure App Service, Container Instance, Container Apps, and Kubernetes Service, right? So I think somebody asked about function and logic app as well. So once we go through this, I'll also talk about those things, right? Yeah. So first thing is, yeah, what kind of applications we can use here, right? So app service, obviously you can put any web application or containers, because the web app for containers is what you will use if you're doing a containerized application. Or you can also very well deploy your .NET DLLs into, like, right click and publish what you do to an IIS server. You can also do it into Azure App Service as well, right? But all the other 3 are primarily for containers. And whether are these a PaaS or a serverless model, it's a PaaS for Azure App Service. Container instance is serverless because we don't know in which particular thing it's going to run, and then it's very lightweight, right? And Azure Container Apps as well, it's a serverless model here. And Kubernetes Service is a PaaS. That means the Kubernetes cluster is managed by Azure, but anything that is within the cluster is something which we need to handle. What kind of networking policies you want to add, what kind of, any other OPA agents or anything you want to do to manage your clusters, how do you secure your clusters, how do you manage your certificates, etc., is all managed within the cluster by us, right? And state management, app service is stateless and container instance is also stateless. Here you can use stateless and stateful, but like I said, I've not tried stateful yet. So I'm not in a good position to comment on how that works. Kubernetes service also, you can use stateful sets. Basically, you have something like stateful set there, which you will use to deploy things that needs to have a persistence in it, right? And when you talk about web hosting, so app service has a built-in web hosting, but other 3 doesn't have any specific built-in web hosting. So you can host your web anywhere, and as long as you have an connectivity to your container instance or your container apps or your Kubernetes service backend, that should be good. That's why it says agnostic there. And how do you now develop applications targeting any of these, right? If it's an Azure App Service, you can very well, if you're on a Windows, you can use an IIS Express, or if you're working with .NET, you can use Kestrel, and you can just build those. If you're working on any other language like Java, you can use Java-based web servers, etc., right? So here for the other 3, I mean, for the other 2, at least container instance and container apps, you can use local container runtime. It could be a Docker-based runtime. It could be an if you're using Rancher, you can use any of the container based runtimes, and you can use that to do your local debugging purposes. And in Kubernetes, if you want to work on it, you need to use something called Minikube, or even for Docker comes up with a Kubernetes run instance in it. Or there are also other Kubernetes offerings available, right? Which we can use. And when we talk about application deployment, right? So there's something called deployment slots, like I talked about in the initial few slides. You can use that to do an app service-based deployment. In the container instance, there's nothing called application update. So it will bring down the current container, then it will bring up a new container of your application if at all you want to do an update. Right? So there's no zero downtime deployment or anything like that. Container apps has revision management, and in Kubernetes, you use something called rolling updates with which you can perform a zero downtime deployment. And auto scaling, yeah, Azure App Service has a built-in service. As someone also pointed out, you have a slider there, you just move it and it will automatically scale depending on your needs. And container instance is not an auto scalable one. It just runs only one instance. Container apps also have scaling rules we can define, like I called out, either via HTTP rules, or you can do a KDA-based rules for event-driven systems. And Kubernetes service has a pod auto scaling plus cluster auto scaling as well. That's also possible there. Yeah, and talking about limits, so there are certain scale limits in each of these offerings. So Azure App Service, you can only run 30 instances of an Azure App Service, and there's only 100 app services what you can run. With an app service environment, if you're running, you can run only 100 instances. This container instance is like 20 containers groups per subscription. It's a subscription level limitation there. You cannot create more than that. And container apps have these restrictions as of now. So these limits are as on date when I picked up, it is this much. It could very well change. As you well know, the cloud offerings are really changing at a much rapid pace, right? Tomorrow also this could become more or less. And container apps, you can have 5 environments per region and 20 container apps per environment. And you can also have 30 replicas per container app. You cannot go beyond 30 if at all you have a need to really run that many replicas, right? And Kubernetes has a maximum of like 5,000 nodes. That stars legend, I didn't put that, maybe I'll update it later. There's something called uptime SLA. If you sign up for that, only then you will get that 5,000 nodes in it. And load balancers, yeah, App Service has an integrated load balancer in it. Container instance doesn't have any support. Container apps also has an integrated load balancer. And if you're working with Kubernetes service, you need to have an Azure load balancer or application gateway. See, again, this is optional, right? When you say container apps, I think someone posted the picture as well. In that particular architecture, the Azure Container Apps load balancer was not used, but an application gateway is used, right? So, but the high level possibility is that if you don't want to use it, and if you want to make it more secure, you can also do that by configuring the right ones. And multi-region failovers, that means, let's say if you are building a global application where you can have your traffic coming from the US or Europe or America, sorry, APAC region, etc., then you might want to have your application running in different regions, right? So if you want to do that, then you can use something called Traffic Manager, which is another service in Azure. You can use Traffic Manager front door in all the cases to enable your multi-region failovers, right? One for failover, or if you want to even manage active connection, you can also do that with any of these. So for example, if anytime my US customers are connecting to my application, I want to route their calls to my US based instance, my API instance, right? You can very well do that with Traffic Manager or front door. So the last point, but not the least one, is around the suitable architecture in which use cases you can use, right? So Azure App Service is more of web queue worker kind of a model where you have a web application, or if you're just dealing with small queues, and if you have worker kind of this one, you can use that. For the container instance, it's more around microservices, but it's all like standalone microservice. Into independent service only you can deploy, not like in container apps where you can deploy multiple microservices into a single environment, right? In the case of container instance, there will be only one instance will be created, basically one container per instance. So you can have maybe 20 containers or something like that. Then you can create each of them independently. So any kind of task automation you want to do with the containerized model, or if you're running any bad jobs, it needs to be run on a scheduled basis, etc., you can very well use container instance, because that doesn't need a lot of orchestration, right? What I mean by orchestration is all these dynamic scaling and then deployment, like rolling upgrades, all these are part of your orchestrator, right? If you don't need any of those, then you can very well go with a container instance. Container apps is primarily for microservices and event driven. Even Kubernetes is for the same. So now the thing is, let's say, like I said, it's more of Kubernetes style based one is what container apps is, but it's abstracting the underlying Kubernetes ecosystem for us. So you don't have to really deal with any cluster or any of those YAML related configurations that is needed to deploy into a Kubernetes service. That you just define a particular image. As long as you have an image available from somewhere, you can very well deploy it into the container apps, right? It's possible to control deployment of Azure Container App, like to deploy to memory intensive or CPU intensive workload. Sorry, I couldn't get it. Can you please elaborate once? Are you asking if there is any CPU intensive workload you don't want to deploy to the container apps, and is that what you're asking? Can we deploy restrict it? And Nikunj, if in case you are, please unmute and then.
Am I audible?
Yes, please.
Yeah, so in Kubernetes environment, you can have a different node pools. So one node pool can be of D series, another node pool can be of E series, and you can,
Yeah,
when you define your YML file, you can set up a role
correct.
or labels which will deploy your app service to either if that app service is CPU intensive, you move it to like or deploy it to basically
Correct.
like a D
Yeah,
series
a
or a E
bigger,
series.
yeah, correct. Yeah.
Yeah, so same way, is there any possibility in Azure container app that we
Mhm.
can have a such role or label defined?
Yeah, labels are possible, but it doesn't really designate where it is going and deploying, right? Because it's more often serverless. That's why there's a difference called serverless versus PaaS, right? So here, what you can specify is for that particular container, what is the CPU limits and your request is what you can define in here as well. Depending on that, Azure container apps will take care of it. It doesn't, I mean, you will not really know under which node pool and under which VM it is running. If you want to have such control, definitely Kubernetes service is the way to go. Yeah.
Okay, okay, got it.
So costing part, yeah, we'll look at the pricing page. It might be cheaper for certain things. It might be a little more for other things. It's more subjective discussion. So yeah, I'll also show the documentation and then we can understand that part. Another question you had was 20 container apps per n. Does that mean we can have only 20 microservices within an environment? Yes, that's correct. Yeah. 20 container apps. Yes. If you're putting one microservice in one container app, yes, we can have 20 in it.
Yeah, but 20 is like too less, right?
Very
Like
less.
environment,
Yeah.
you mean to
Yeah.
say environment means like dev, test, acceptance, production, such
No, no, no,
environment or
not that.
something
The
else?
container apps environment. So container apps has an environment, right? Like what I showed in the first slide here.
Yeah, but I didn't get exactly the
Mhm.
purpose of that environment. Is it like a logical boundary, physical
Yes,
boundary,
it's
or
it's a logical boundary. So if you go to a first slide, right, what I talked about here. So whenever you create a container app, you need to create an environment on top of it, right? That's the isolation boundary here. In this, you can have multiple container. That means you can have like 20 container apps as of now. Let's see, this is something which went GA very pretty recently during build,
oh, is it like
right? Yeah.
something like a namespace in a Kubernetes maybe?
Correct. Yeah, you can link to
Just a
that way. Yeah,
guess.
correct. Yeah,
Okay, okay,
not exactly namespace, but yeah, this provides basically an isolation at a VNet level. So that means it can be a single in a single cluster. You can think of like a small cluster. You can think about it, right?
oh, okay.
Because the container app is what is going to host your actual replicas inside
Mm-hmm.
it. So this app could be like your namespace because you are not you are basically having only one sort of one set of containers in it. When I say one set of
Yep.
like a primary container plus its sidecar if need be.
Yep.
Right? That's
Yep.
how it
Yep.
is. Yeah.
Okay. Yeah, maybe 20 is too less, but hopefully that limit will
Yeah,
change in
I think
future.
it will increase. Yeah. Like I said,
Yep.
it's just
Yeah.
when it's pretty
True.
evolving one.
True.
So yeah.
Get it. Got it. Thanks. Thanks.
Okay. No worries. Yeah. Back where we were in the why part of the comparison part of it, right? Yeah. So all the pictures, everything, I took it from the Microsoft Learn websites only. I'll also show that now as part of the demo. So yeah, everything is neatly documented. We can go through it and then we can really, get started with this. So yeah, so now let's quickly jump to the demo. Oh, it's already 12:55, is it? Okay, so then in the interest of
Swami, I
time,
have a
what?
quick question. I'm sorry.
Yeah.
For that, I want to share my screen and just show the diagram so that I can ask this question. Can I?
Yeah, sure.
Uh,
I hope you
yeah.
have access. I'm not sure. Okay, yeah,
Yeah.
I'm seeing it.
Can I see my screen?
Yeah.
Yeah. See, what I'm doing is like, I've just shared the diagram. Right? It's very similar, but here I'm using app service, and I put these two app services in a separate subnet. And the database, I'm saying like, no, though it is going to accept the traffic only from the app subnet, not from the web subnet, because only the app can access the database. It's for a security thing. If I want to do the same thing on the container app, see here, we have the subnet configuration at the environment level. So here, if I just say at the database level, go and allow this subnet, then here the problem is like even the member portal can access the database. So my question is, can I have this is my question, is this assumption? So you can just tell me that's right or wrong. So what I'm thinking is like, can I have a separate environment, one for the web and one for the app, and I can have a separate environment and have separate subnet for each and every environment, and I can say SQL Server just go and allow the subnet that belongs to the app. So what is your recommendation in this one? So I just wanted
See,
to achieve something
while
similar to this one.
yeah, well, technically it could work, but again, it will add latencies and other things, right? Because the moment you create another environment, you need to come via your external ingress URL only, right? The internal ingress will work only if all are co-located within the same environments, right? That means all are in the same VNet, right?
Of course,
And
they are going to be the
also,
same net, but
yeah, so
it's
you don't
same net
have
but different
the
subnet. Yeah.
yeah,
Yeah,
so I
please.
don't think you'll have an option to choose any subnets within container apps. At least I have not tried that yet. Okay, because since it's more of a serverless, you don't have that granular control of okay and where it is working. If you have a VNet, you can assign that. But within that, if you do you choose any subnet to something? I've not tried also, Kanan. So yeah, I might also need to double check on that part. Yeah.
Yeah, but if I have VNet, then it is of no use. I have to have subnet under the VNet. Only the subnet can be assigned to the applications, whatever resources
Yeah.
we have on Azure. It's like that. So we should have subnet. That's for sure. So your thing is like we should have both should be in the same environment. That's what your recommendation, right? But
Correct.
here
Yeah.
my thing is then there'll be a security vulnerability, right? Because my member portal can access the database. So
Yeah.
there'll be a security vulnerability open
Yeah,
here.
so that also can be maybe worked through it differently. See, we should not be just relying only on the subnet level accesses alone. right? That's where actually, even if you use you can also use manage identities in that case, right? Then you can assign a manage identity for your backend controller, backend app, container app, and only with that you can access it instead of going via your traditional connection strings, right? If it's connection string approach, then anyone can really access it, right? So you can enable that AID based authentication, and then enable the manage identity for your backend container app, which is running within one VNet, and then you can use that to connect to your Azure SQL. That way
Perfect.
you
Yeah,
can.
here
Yeah.
exactly. So I'm just here. I'm doing that only. But again, my question: manage identity is really good option, but can have a manage identity at the container level, or should be at the application environment level?
No, it's
How
at
about
the
this in
app
containers?
level. App level, if I'm not wrong. Yeah.
If that's the case, that is my answer.
Yeah.
I got the
Yeah.
answer.
Okay.
Perfect.
Okay. Great.
Thank you so much.
All right. Thanks, Kanan. Right. So going back to any other questions from anyone? How much time I have? I already exhausted the time. Is it?
No, please take your time, complete the demo, no issues.
Okay, sure. Yeah, maybe I'll try to keep it quick. I want to do a live demo of creating things, but I don't have time for that. So to create it quickly, you can just go here and then say create, and then you can choose which resource group you want, and then you can see that it already chosen the container apps environment what I've created. Right? Otherwise, you can create a new environment if at all you're trying to create a new one, right? And from the region availability perspective, these are the regions where it's available as of now, like US, Europe, and then some part in APAC, not in India data centers yet. But yeah, this list will keep on growing as this service become more popular or so, right? And when you start, you can create any of the name. Let's say, for example, I'll just say live demo. And then app settings, you can choose how you want to start it. You can very well start with a quick start image. That way, automatically you'll get a container app instance up and running. And this is because you're choosing quick start, it is showing this. Otherwise, I can uncheck this, and then I can choose any of my existing, this one as well, existing container registries. I have one image here, I believe. Yeah, this is a web API demo which I created. This is what I have it here. So then I can choose the tag, and then I can choose the Linux, and any kind of thing I want to override here, I can do it. And then CPU and usage is what I can define here. Someone asked about the limits as well. So this is what it is currently having: 2 CPU cores and the 4G memory. This is the resource allocation. Basically, this is what will go into your resource requests in your this one, if in terms of Kubernetes side, right? And if there are any other environment variables, you can define those, and you can click whether you want to enable ingress or not. Right, so that's how you will create it. I have actually created one. I'll just quickly show that. So this is the one which is created with an the quick start image. Oops, sorry, wrong click. So once you have an ingress enabled, as you can see here, the ingress is enabled here. Then you'll get an endpoint like this. If you just hit it, it is going to show the basic whatever the image we have pulled in from, right? The hello world image. It just shows it welcome to Azure Container Apps, right? That is the hello world part what we have. Right now, talking about how we deploy our .NET applications to this, right? That's what I created this, and then I have already deployed it. So what I did is basically, yeah, there are quite a few. There are multiple ways to do it. So since I'm on a Mac, I don't have Visual Studio 2022. If you're on Visual Studio, if you're on Windows and if you're using Visual Studio 2022, you can always right click and then publish, like how we traditionally used to do any .NET application. And while publishing, instead of Azure App Service, you can choose Azure Container App, and then you can deploy it into your Azure Container App. Again, you can directly deploy it, or you can also create GitHub action directly from it. Yeah, right. So what I've done is, let me see if I have those logs present. I was planning to show that only here. Maybe let me see if I can still do that. That's starting Zish. Okay, now let's not waste time. Okay. So easy container lab demo. Yeah, so this particular repository is having a basic .NET Web API file new .NET new Web API. If you do whatever the application comes up, that's what I'm having here, right? So what I did is I used the steps present in here basically. So if you go to the documentation, right, like I said, everything is in the learn neatly documented. I also use this only to prepare this demo, right? So you have this file or this particular page. The reference is already added in the deck. You can also share it here. So there's an option to actually deploy it from your GitHub repository, right? So what I did is I created a basic .NET Web API, like I showed, in my local. I created it, and then I pushed it into this particular repository, and then I ran this command: Azure Container AZ Container App up with the name as my container app name and the repo URL and the ingress. All right. So basically what it does is, I'll also show that I have it here. Yeah, so let's say this is the command which I ran, whatever I'm highlighting here, right? AZ container app up with the name as CA web API pug demo, and then repository name I've given as this repository, right? With an ingress as external. So then what it does is it basically first allow me to connect to GitHub and then get my PAT token, right? And using this resource group, using this container app environment, I don't have to define it because I'm trying to deploy it into the same environment. If at all you want to change it, you can very well change it in that container app command as an argument. Then it creates a registry for you first time if you don't have any registry. And then it also created this container app for me. And it created a service principal, and it created a GitHub action, and then it basically ran the action as well, right? So by the end of this GitHub action, so and what the GitHub action does is this. If you go to your, no, that's why it says auto deploy. So if you go here, you can see what are the things, or maybe I'll open it in VS Code for better readability. Oops, what happened? Coming up. Okay, so this is what is this particular file is having. I'm not going to explain a lot of it. So this is the GitHub actions on event part, how what needs to be done. And then these are the different jobs. Basically, it is setting up the Docker build, logging into the ACR. And then it is building and publishing the image to the ACR. And finally, in the deploy step, it is actually using my Azure login with the federated credentials. And then it is trying to basically run this AZ config, it is setting, and then config registry, blah, blah, blah. These are the three commands it is basically running to push my application into the container apps, right? So when this guy ran and completed, I kind of get this this API up and running, right? So now to check what it is doing, it's a fairly straightforward one. If I just click on that ingress URL and just say weather forecast, right? Then that API, whatever the API we have, the default API, right? The web API, that is what it is returning, right? So now let's go through some of the aspects here in the portal, right, for the container apps. So the ingress is where you will go and manage your ingresses, whether you want to enable an external one or you want to enable internal one. So as you can see here, there are multiple options. I've enabled ingress and then I said accepting traffic from anywhere. Of course, you wouldn't do this in your production related stuff. Since it's demo, I'm doing it. You can limit to your container apps environment if you want to. If I have multiple apps in it, I can go and change that here. And I can also change ingress type and what port I'm listening there, and then what are the IP restrictions here. Even though I say it's allow traffic from anywhere, I can even again add some more IP addresses if I know like when a specific VNet or anywhere I want to enable access, I can very well do that as well here, right? So this controls both your external entry endpoint, external entry point, plus if you don't want that to make it external, if you want to make it only internal, you can also do that here, right? This is one important thing. And the revision management is where you will go and manage multiple revisions here, right? So for example, I think I have one revision which is currently up and running, right? So if you look at the container details, it'll go and show what are the containers that are running as part of that revision. This is the number of CPU cores. This is the number of this ones, right? So for example, if at all I have to create a new scaling rule, I think I create a scaling rule for this. So yeah, before that, as you can see, revision mode, I'm using single. That means I'm going to have only one version as an active one. I can go and change whether I want to have single or multiple. If I say multiple is when I will be able to then start adding my traffic rules here. Right, so it might take a bit of time.
Also, please show how to delete the revisions.
Okay. To be honest, I'm not deleted it. I'm going to try it live now. So once I have this show inactive versions, yeah, so I think, yeah, I've been deactivated. It will bring up a new revision now, and then I should be able to basically go and change the traffic thing here. And yeah, for example, let us go and add some scaling rules, right? That was one demo which I wanted to show. So the point is, the first thing is, yeah, we saw how easily we can deploy it via GitHub Actions. We can push it into the container apps. And then now when we talk about the scale part, I am just trying to choose this particular image. For this, I want to set, I have already created a rule called concurrent request based scale, where I mentioned it's an HTTP scaling. Here's where you can use either a HTTP scale or an Azure queue or whatever, right? If you go scale rule, you can choose that. I think it's the same HTTP scaling or Azure queue or custom. Custom is where you can define what are the references and things like that for this particular image, what you want to do. Right. So for simplicity, I've used HTTP scaling here and say a concurrent request. Right. So let me go and edit that existing one. So I'll say concurrent request if it's 10 is the one I've enabled, and the number of minimum is 0 and maximum is 5. For example, I want to increase it to 10, right? And then I can say create. Then it's going to create another revision and it will now deploy that new revision, right? And as that happens, we can also try and do some more load testing here. Okay, it has deployed. So now as you can see, since I've enabled multiple revisions, it says this is the one which I deployed on 15th, and this is the version which I just deployed now. And here I can go and split the traffic. So for example, I want to push only 20% of traffic here, and I want to push like 80% to this particular this one, right? I can do those rules changes. And then when I now start hitting my API endpoint via this ingress URL, some requests will go to this and some requests will go to this. So how we identify is something we can use log analytics and things like that, which I don't have time to show now. But one thing what I want to show is the high level metrics, at least what we are having. The revision mode is here. Yeah, the deletion part, I need to check again. I think it was Kanan who asked, right? I'll need to check and then I'll get back, okay, how we can do the deletion of these instances. I don't remember seeing anywhere.
Because we didn't see, I tried, but I couldn't find any option to delete it.
Okay.
And also they
I think
say
it's an automatically it will it's like a rolling thing, right? Once you reach 100, the earliest one will get deleted is what my hunch is. But yeah, I've not gone till 100 yet, so I've not really explored that yet. Okay.
Yeah.
So yeah, so if you go to the metrics part, we can look at these are standard metrics that comes out of it, like how many replica count are there. Right now it says only 1, and then the moment we start adding more load, it would start really creating more this one. Just to quickly simulate that, what we can do is I'm going to hit this API using an Azure load test. Has anyone used Azure load test? This is another preview service with which you can quickly run a small load test and all without installing anything on your local machine. I'll say number of users is 5, and I'll just say this is 60 seconds. This is 0, and then say run test. Then it will automatically start running my tests, right? And it will start, and maybe it'll run for 1 minute. And after the minute or so, if you go here and then take a look at our number of instances, it should automatically go up as the tests run, basically. It just will head to start. Meanwhile, any questions? I know I'm a bit rushed in the demo part. Sorry about the time and missed time management. Any other questions as it runs? Yeah. So this is how it will generate the metrics for us. It auto refreshes every 5 seconds. After a minute, we should be able to see the data, how many requests it has placed, and then that also would create and scaling here for our app, this one, apps, container apps, basically. Yeah, so as that happens, maybe log stream, if at all you want to open a log stream, you can just click on here the same way how we do for Azure App Service. We can connect to that, and here you can choose which revision and which container, etc. So this is what it is. Actually, this is the log which is happening. I mean, of course, it's a simple application, so there's not many logs which are being written, but I hope you get the idea, right? And then if you want to connect into any of your console, right, you can choose which revision you are logging into, and then you can start with this, and then say this will enable and connectivity to your container that is running within your container apps. So typically, if you're running within your Kubernetes, you might use something like Kubernetes CXCC or whatever, and then you will navigate to a terminal, and then you'll do that, right? So the same thing you can do here. So now we are within the terminal of our application. So if I just say, so this is my .NET application, and the DL is what we have really published into this app folder, right? So for example, if you're working with an microservices where you have one service not able to talk to another service, right? Then you can quickly go here and then do a curl and then check if the connectivity is established between this and the dependent service, etc. That is when this would be handy for us when we are working with container apps. Okay, now let's go back and see if this was able to complete. Did it complete? Okay, yeah, so it was able to pump in this many requests here now, right? Now let's go back here to our metrics and see if it's able to populate that. Oops, account. Yeah, as you can see, it has spiked up till 10, right? Because that's the maximum revision which I've added now, right? It can go up to 10 is what I said, the rules. So it was able to go till 10, and maybe after a few minutes, if you look at it, it'll again come down to 0. Yeah. Yeah, so that's a pretty quick whirlwind tour. Yeah, if you want to use Dapper or other things, we can go and configure here. So like I said, everything is more of configurable either in the portal or you can do via the AZ options, right? And identities, you can go and set up the manage identities here. Or if you want to use any external authentication, there are also IDP supports available here. As you can go here and see, if you say add identity provider, you can choose from any of these Microsoft, Apple, Facebook, Google, Twitter, all these you can use, and then you can set up your authentication as well. And yeah, so continuous deployment is where you can go and see how the deployments are set up. It automatically shows to this particular organization, to this particular user, and in this repository is when this is pushing. So anytime I add and make a change, and then push it to this repository to this main branch, it will automatically pull it and then deploy it. Right. Yeah. So I think that's pretty much. I don't want to take too much time from the next Swami's session. I hope it's yeah. Okay, let me stop here and take any questions if there are.